So the first thing I always try to make sure that people are clear on is why, the question of why. Why do I need to divide polynomials? And the answer is because you can't factor. Okay, and if you can't factor something, then you're not going to be able to solve this when it equals 0. All right, so our end goal is to be able to break this polynomial down into its factors. And we can do this when the factors are relatively easy numbers, but we cannot factor this down in this instance. So we need another strategy, and that other strategy is polynomial division. And we need to practice that. And there's two ways of doing polynomial division. There's synthetic division and there's polynomial long division. Synthetic division is a shortcut. But to understand the shortcut of synthetic division, you really have to go back to when you learned how to do long division. So long division, when you were asked something like, 642 divided by 5. And there's different ways this is written, but I think you'll be able to follow and remember back to in 4th grade or 3rd or 4th grade when you learned how to do division. You would ask yourself, okay, I'm asking how many times can 5 go into 6, right? 5 can go into 6 1 times. 1 times 5 is 5. And then I subtract, bring down a 1. I bring down the 4. 5 will go into 14 2 times. 2 times 5 is 10. I subtract. I bring down the 2. 5 will go into 40 8 times. 8 times 5 is 40. Bring down a 2. Okay, this 2 represents the remainder. So like you could say 128 remainder 2. That was usually the first way kids are taught. And then you could say, okay, 128 in 5 halves. And if you wanted to go and you didn't want to do it as a fraction, remember you put a decimal place and you could say, oh, I'm going to bring down that 0. 5 will go into 24, so I could also write 128.4, right? Those are all the different ways that we could talk about it. We're most interested in, when we do polynomial long division, if we're talking about the remainder in this way, so that, or even this way. All right, but we're really interested in how can I do this kind of division with polynomials. And synthetic division, like I said, is a shortcut, but to really understand the shortcut, we can look at it first in terms of comparing it to what we did here. So now we're going to say, all right, we're dividing this polynomial, and in the question we're using, we're dividing by x minus 3. So I'm asking myself, I want to eliminate this first term, right? I want to get rid of it, make it be 0. So I can ask myself, how many times will x go into 2x cubed, or how can I create 2x cubed? What can I multiply by is the better way. So if I want to multiply something by x to get 2x cubed, I have to multiply it by 2x squared. And now we do the same thing. After we had the number here, we multiplied. So 2x squared times x is 2, oops, I got an eraser here, is 2x cubed. And now I need to multiply the other part of this binomial. Is going to be minus 6x squared. I have to remember to subtract. So when I subtract this becomes 0x cubed, and most of the time you won't see that written. They'll just put a dash through it. And then here I have a negative times a negative. So what I do is I just remind myself this is going to be positive. And so now I have a negative 7x squared and I have a positive 6x. So this is going to become minus x squared. Now I need to be a little bit careful here because I want to bring this number down, but I'm missing something here. I had cubed, I had squared, and I'm going to run into a problem if I don't create that x term. All right, so I'm just writing this, making sure, and you could have done this, by the way, at the very beginning. I could have at the very beginning said plus 0x plus 5. Whenever we're doing division, we want to make sure we have we go down from the highest value to the low, to having 0 up here, right? There's 0x. So now I'm back to where I was. This is gone. I'm now stuck. I'm here. I'm wanting to add or subtract something here so that I get negative x squared when I multiply it by x. So I'm going to have to put negative x, right? Because negative x times x creates a positive, all right, creates a negative x squared. And then this creates a positive 3x. And now I have to remember that I'm subtracting. So when I subtract, this is gone. I'm left with negative 3x because a negative times a positive makes that negative. And I have that 5 just being written down here. So now, again, how do I get 3x by multiplying it by x? I'm going to have to multiply it by a negative 3. Negative 3 times x makes negative 3x. Negative 3 times negative 3 makes a positive 9. I remember to subtract. All right, so this is going to make this here, and I'm going to have a negative 9, so this is going to be negative 4. So that's polynomial long division, and that's kind of the long way. So let's get rid of this for a second so we can do this right beside here. I want to get rid of this. I want to cut that out of there. All right, this. Don't know, sorry about that. There, we got rid of that. So remember our goal was to figure out how to use synthetic division. So in synthetic division, what I do is I have to take the value so if I said x minus 3 equals 0, x would equal 3. And this is the value I want to meet. So I have to do the opposite of what I see. So that number comes outside of this box. Inside of here, oops. All right, we actually write this box. We actually put the box in the opposite direction here. We make this box. Now, I want to take the coefficients. So these are the coefficients. I want to take the coefficients and the constant, and I want to put them inside the box. So I have a 2, a minus 7, a 0, and a 5. All right, now the first step is to drop down this 2. So I just bring this 2 down, and now I multiply. 3 times 2 is 6. And here's the biggest difference between synthetic division and long division is I'm going to add these numbers. Okay, these numbers all get added. So negative 7 plus 6 is 1. And now I multiply. 3 times 1 is 3. 0 plus 3 is 3. 3 times 3 is 9. Sorry, this is negative 1, makes this negative 3. I forgot that. Negative 7 plus 6 is negative 1. 3 times negative 1 is negative 3. This is negative 9. And this is negative 4. Now, so let's just review one more time what I did. I wrote down, I have to take the value that x equals if I was factoring. I put that out here. Right? I'll just kind of go over these again. I put that out here. Then I take all the coefficients and I write them along the top. Now I drop down the first number and I start the process of multiplying add. So it's multiplying followed by adding. So 3 times 2 is 6. And I add negative 7 plus 6 is minus 1. I'm back to multiplying. 3 times negative 1 is negative 3. I add. I get negative 3. I multiply. And I add. Now, what do you notice about these things? Right? Well, look, here you're getting the exact same values. Right? And this position right here, whatever is here, this is your remainder. So when I'm all done, I can rewrite kind of what has happened with either one of these. I can write what has happened. So what has happened? I've taken 2x cubed minus 7x squared plus 5. I've divided it by x minus 3. And what does it equal? Well, it equals, I can either use up here, it equals 2x squared minus x minus 3, which I could get up here, right? I could get from here. Or these are the coefficients. And now I just have to deal with that remainder. So in this case, it's a negative number. So it's minus 4. Right? And that minus 4 is still being divided by minus 3 because I haven't gotten rid of it. So this is the remainder. Now, remember at the very beginning we said, what's our goal of all of this? Well, our goal of all of this is to find the factors. And it'll be a factor. This number will be a factor of what's above it if there is no remainder. Right? And so your goal, and there's some other little tricks in the lesson. There's other things that can happen when we use synthetic division. But if our goal is to find the factors, we're going to get no remainder. Right? And this is asking you to do first is walk through and make sure you can do these two kinds of divisions. So I hope you find this helpful in that problem and